Good day to you. This is teacher Leland Alejandro, and we're going to discuss today rate of change or average rate of change of a given function for a given interval of the independent variable. Okay, so we're going to see the problem set and solve the problems from it. All right, here's the problem set and okay, let us see first the entire problem set. Okay, so this is the entire problem set, and this is average rate of change. These are considered lecture examples. So we will be solving this one by one. And let's start with the first one. Okay, for each problem, find the average rate of change of the function over the given interval. So for the given interval, this will be the values of x, the independent variable x. Now, the very nature of the average rate of change has a formula equivalent to the slope, equivalent to the slope. So if we're going to describe its formula, it will be represented by m. And then for a given interval, say for example, interval x1 to x2, these are two values of x, okay? And x2 is the higher, x1 is the lower. So in the line graph, the x-axis, you can find the x2 at the right and x1 at the left. So x2 is supposed to be higher. And you'll be able to notice that when you see the given numbers. You can see here -1 and 2. The one at the right is the higher, the 2, and the -1 is the one at the left that is lower. This is not a point, okay? It's not a coordinate. That is not xy, okay? That is not xy. So this is actually two values of x, and x2 is the one over here, and x1 is the one at the left, okay? And you can see the symbols used. It's the square square brace, okay? So not the usual parentheses. That's why this is not a point, xy. It's x1 and x2, x2 being the higher. All right, so we need to explain that, and the slope formula that we used to apply is y2 minus y1 divided by x2 minus x1. Now, in our solution, we will have to compute y2 using the x2. So to solve for the function, okay, using the x2, it's supposed to be y2, which is actually f of x2, like that. And then y1 is f of x1, there. And so this formula becomes, okay, it becomes f of x2 minus f of x1 over x2 minus x1, like this, okay? We can write it over here. M is f of x2, the value of the function at x2 minus the value of the function at x1. Okay, we're going to get the difference and then divide this by x2 minus x1. This will be our formula for the average rate of change, for the average rate of change. So we shall use this formula in the given problem. Okay, so let us start, and I hope you'll be able to apply this correctly. And let us clear the screen and answer the question. All right. So here is the given function. This is y equals x squared plus 2x minus 2. So we can write this as function of x. So y is function of x, which is equal to x squared plus 2x minus 2. Now we're going to find the average rate of change from -1 to 2. Okay, so that our interval is -1 to 2. And that makes x1, let's begin with the higher. Our x2 is 2, and our x1 is -1. We shall write it over here. X2 is 2, and x1 is -1. Yeah. Okay. So in the formula, we need to get y2. Okay, y2, and that's what we need in the slope. Okay, the average rate of change of the function. And so we can write here y2 is equal to f of x2, like that. Okay, and this is supposed to be equal to f of 2, because our x2 is right here. So that means f of x2 means f of 2 there. And we're done with the functions. We're done using this in a previous lesson. So that means the number 2 will be placed in all x variable you see in the equation. So this will now be 2 squared plus 2 times 2 minus 2 there. And so we will be able to get this value, which is 4 plus 4 minus 2, and this becomes 8 minus 2, which is 6. So our y2 is 6. All right, and this is also equal to f of 2. Okay, now how about y1? Y1 is f of x1. F of x1, which happens to be f of the value of x1 over here. Okay, that's -1. So f of -1. This time we go back to the given equation, and all x will be replaced by -1. So this is x squared. This means -1 squared. Okay, plus 2 times -1 minus 2. We're using this. Okay, we're actually using this. Okay, so it's -1 squared plus 2 times -1 minus 2, and we shall find the value, and this will now be y1. Okay, y1 is equal to -1 squared is a positive 1, plus 2 times -1 is a -2 minus 2, and that should give us about 1 minus 4, and that should be a -3 there. So we're now going to use the slope. Okay, the slope formula for the average rate of change is y2 minus y1 over x2 minus x1. And this shall be y2. Okay, y2 is here, 6 minus, all right, get your y1. Your y1 is a -3. So after the minus in the formula, we shall write -3 there, because that's the y1, and so this is divided by x2 minus x1. x2 is 2 over here minus x1. Our x1 is another -1 over here. So after the minus in the formula, we write -1. There. All right. And we will have here 6 plus 3 divided by 2 plus 1, which gives us 9 over 3. Our answer is simply 3. There. That's the answer. So m is equal to 3, or average rate of change in the interval -1, 2. Okay? All right, so we shall verify the answer. All right, over here. Okay, there's the answer. M is equal to 3. All right, so I hope you were able to follow the way to do it. All right, this is the first number. Let's continue with the next. All right, let's have the next problem. Okay, here's the next problem. The same instruction, find the average rate of change of the function over the given interval. Okay, so we shall use the function y, okay, and we shall denote it y is equal to f of x is equal to -2x squared minus x plus 1. Okay, and we shall denote the higher value here. The interval is here from -2 to 1. So the higher value is our x2. Our x2 is the positive one. Our x1 is the -2, the lower value. Okay, so we shall get the value of the function at x2. So we have here f of x2 is equal to f of 1. Okay, and this is now -2. All x will be using the value 1. So this is -2 times 1 squared minus 1 plus 1. And this will be -2 minus 1 plus 1. This is simply -2. And this is the value of f of x2. Okay, f of x2. Yeah, and this is actually our y2. There. Okay, next. So we shall put here y2. There. Let's compute now our y1. Okay, y1 is f of x1 is equal to f of, let's get the value of x1. It's over here. It's -2. Okay, there. So this is now -2. And we shall use the same function here. And replace all x with the -2. And so this is -2 coefficient times the quantity x squared. And what we will put in x is the -2. There. Then minus x means minus -2. There. Plus 1. And so this is -2. -2 squared is 4. And this is plus 2 plus 1. So this is -8 plus 3. That should be about -5. -8 plus 3 is a -5. And that goes to our y1. Okay, so we're now ready to solve our m, the average rate of change. Okay, so m is equal to y2 minus y1 over x2 minus x1. So our y2 is over here. Okay, all right, I will just enclose them. Okay, y2 is -2. So we write here -2. And then minus, that's from the formula. Okay, take now your y1. Your y1 is over here. Okay, that's a -5. So after this minus, it's a -5. like that. And then this is divided by x2. Our x2 is over here. That will be 1 minus, get your x1. x1 is the same, -2. So after the minus, we will write -2. So this is -2 plus 5. You see, minus negative becomes plus. And so this is -2 plus 5 divided by 1 plus 2. And that gives us 3 over 3. Okay, a number divided by a number is equal to 1. And that's the answer. Our m is 1. And we shall verify that. Okay, it's over here at the left side, the red number over here. M is equal to 1. Okay, so that's the answer. That's the average rate of change of the function for the given interval. Okay, all right. So that will be for our number 2. Let's continue with the next number. I hope you were able to get that. All right, let's continue with the third. Let's clear the screen. Okay, let's go to the next. All right, here's the next one. Find the average rate of change of the function over the given interval. Okay, so same as the way we did 1 and 2, we shall proceed the same way we did the first and the second. All right, so we now have f of x. That is our y. And what's given is x squared plus x plus 1. Okay, from the interval -3 to -2. So the lower is the -3. The higher is the -2. Okay, the more negative, that's the lower. Okay, all right. So this x2 is the -2. Okay, so we shall write over here the left side. This is -2. Our x1, that's the lower -3. In the number line, okay, in the number line, -2 is here and -3 is there. Okay, so the one at the right is the higher. All right, not because all right, the the one at the right is always the higher, and -3 is at the left side, so that's lower. Okay, do not be confused with 3 and 2. Okay, in negative numbers, the higher the magnitude, that's the lower. So -100 is lower than -2. Okay, all right. So you can see that in the number line. All right, just a little clarification there. All right, let me remove my writing there. Okay, let's continue with first computation. So this is y2. So let's start with y2. And this is f of x2. And that will become f of the value here. And that's a -2 there. Now, all x you see in the equation will be replaced by the -2. So this is x squared, that means -2 squared. Don't forget to include the negative sign, okay? It's a -2 squared plus -2 plus 1. Okay, this computes to 4 minus 2 plus 1. So this is 4 minus 2 plus 1. That makes it 5 minus 2, which is 3. And this is your y2 there. Okay, we proceed with y1. y1 is f of x1, which is f of our x1 is over here. Okay, and that's a -3. F of -3. This time we use the given, okay, such that all x will be replaced by -3. So we're still using this. We're still using that. Okay. Okay. So we have now -3 squared, and then plus -3 plus 1. And this computes to -3 squared is a +9, plus a -3 is a -3 plus 1. So this is this will become 10 minus 3, which is 7. there. And this is our y1. Okay, so we now have our y2 and we have our y1. So you can start with the formula. M is equal to y2 minus y1 over x2 minus x1. You can also write this like f of x2 minus f of x1 divided by x2 minus x1. You can also write it this way. And so our values are 3 minus 7, 3 minus 7, okay, and divided by x2 minus x1. So that means negative 2 minus negative 3 there. And so this results to negative 4 over negative 2 plus 3, that's a 1, okay? Negative 2 plus 3, that's a 1. So the final answer here is negative 4. M is negative 4. That's the answer. And we can verify that it's over here. M is equal to negative 4. All right, so that completes our third example. We shall continue with the next. Let's have the next. So we shall just clear the screen and proceed to number 4. Okay, let's have our number 4. Okay, find the average rate of change of the function over the given interval. Okay, all right, let's have this number 4. This is now y is equal to f of x, which is equal to 2x squared plus x plus 2. This is the given function. Our x2 is the higher, that's the 1, and our x1, it's the 0 there. So we shall continue with y2. This is f of x2, and that starts with 2 times the value of x. All right, let us rewrite once more. Let us rewrite once more. Okay, this is f of x2. We shall use the x2 value over here. That means f of 1. And this is equal to 2 times, let's substitute now, 2 times 1 squared plus 1 plus 2, which is equal to 2 plus 3, which is 5. Okay, so we have the value f of x2 equal to 5. And this is our y2 there. Okay, all right. Let us now compute y1. Our y1 is f of x1, which is also f of 0, is equal to 2 times 0 squared plus 0 plus 2. And this simplifies to 0 plus 0 plus 2. That's also 2. And that is our y1 equal to f of x1 equal to 2 there. Okay, so we shall now compute our average rate of change. M is y2 minus y1 over x2 minus x1. And that is y2 is over here. It's the 5 minus y1. It's the number 2 here. So that means 5 minus 2 divided by x2 minus x1. Okay, x2 minus x1. All right, so this is 1 minus 0. This is 3 over 1. That's 3. Our answer is 3. The average rate of change is 3. This is the answer. And so we can verify this over here. All right, you can see the answer at the left side there. So m is equal to 3. All right, so that completes our number 4. Let's continue with the next number. Let's have the number 5. Let's clear the screen. I hope number 1, 2, 3, and 4 are clear to you. Let's continue with the next number. Let's have number 5. Okay, what is the average rate of change in the function f of x equal to square root of x plus 2 over the interval 1 to 4? Okay, so we have a bonus graph here. And all right, we have the points. Okay, we have the points here. All right, and we can very well see our higher point is at 4, 4. Okay, our higher point is at 4, 4. Our lower point is at 1, 3. Okay, 1, 3. So we can easily solve for the average rate of change. Okay, average rate of change. All right. Now we can make use of these points, or we can use the function. Okay. All right. So let us use the longer method first. All right. So what we have here is the function x. Function of x is square root of x plus 2. There. Okay. Let us denote our x2 and x1. Our x2, let me write at the right side. X2 is the higher, for our x1 is the lower, that's the 1. Okay. These are interval. Okay. That means 1 and 4 there. Okay. 1 and 4. And that is actually this point and this point in the graph there. Okay. And so we shall use f of x2 for y2. Y2 is f of x2, which is equal to f of 4, which is now equal to square root of 4 plus 2. And this is equal to square root of 4 is exact. Okay, it's 2 plus 2. Our value is 4. There. That gives us our y2. Okay. All right. How about y1? Y1 is f of x1, which is equal to f of the value of x1, which is 1. Okay. Over here. Okay. So this is equal to square root of 1 plus 2, which is actually 1 plus 2, which is 3. And this is our y1. Okay, we can now compute our average rate of change, which is actually the slope. So m is equal to y2 minus y1 over x2 minus x1. And this is y2 minus y1, that means y2 minus y1. Okay, divided by x2 minus x1. So x2, that's 4, minus x1. Okay, so that will be 1 over 3. It's a 1/3. Okay, it's a 1/3. All right, now looking at the graph, if you're going to see this graph here, let me remove my writing there. If you're going to read the 2 points there in the graph, you can see the higher point is 4, 4. Okay, you can see the higher point 4, 4 there. And this is x2, y2 there. And the lower point, okay, the lower point is at 1, 3. Okay, the lower point is at 1, 3. And this is actually your x1, y1 there. And so looking at your coordinates, you can see exactly those numbers in our computation here. Okay, you can see the 4 and the 3, the 4 and the 1. Okay, it is actually used in this formula. Okay, all right. So I hope everything is clear here, and we were able to get the answer 1/3. All right. So let's check and verify. All right. There's the answer. You can see in the red writing. It's over here. There. Okay. The slope is 1/3. All right. So that completes our number 5. Let's continue with number 6. Let me erase the screen. All right, let me continue with next number. All right, we have a problem here, a worded problem. The height h of a falling object, t seconds after it is dropped from a platform 700 feet above the ground, is modeled by the function ht is equal to negative 16t squared plus 700. So the equation for the motion problem, we have it ht equals negative 16 t squared plus 700. There. Find the average rate at which the object falls during the first 5 seconds of its fall. Okay, first 5 seconds. So it starts with 0 second, then 1, 2, 3, up to 5. So we have the interval 0 to 5. So we can make use of a formula so that our T2 is the higher. So we can make use of T2, that's the 5 seconds, and T1, so the object is dropped and it starts with 0 seconds. There. So our rate of change here will be something like M. This will be H of T2 minus H of T1, and this is divided by T2 minus T1. This is our working equation. Okay, so we're going to solve separately the H of T2, okay, H of T2 and H of T1, okay. All right, so we can make use of this formula later, right? We shall start with computing H of T2. All right, so we shall begin with H of T2. We shall try to write everything in this small screen. So H of T2, all right, H of T2 will be H of 5. Okay, we're going to use this, of course. All right, so this H of 5 is equal to negative 16, 5 squared plus 700. There. Okay, so this is now equal to negative 16 times 5 squared, that's 25 plus 700. Okay, so we have negative 16 times 25, that will be a 16 count of 25. So that will be about 100, 100, 100, 100. That should be about 400. Okay, so this is negative 400 plus 700. That gives us positive 300. Okay, there. So this is our H5 or H of T2. There. How about H of T1? Well, T1 is just 0. So all letter T that we see becomes 0. Okay. So we have here H of T1 which is equal to h of 0, that is negative 16, 0 squared. Okay, we're still using this, of course. So negative 16 times 0 squared plus 700. And that will be 0 squared, that will still be 0, times negative 16, that will still be 0. 0 plus 700, that will be 700. There. So we have the value of h of t1. H of t1 is equal to 700. Now let's compute the average rate of change. Okay, average rate at which the object falls. We'll be using this formula over here. Okay, that will be m. Okay, so h of t2. All right, h of t2, that's 300. All right, so 300 minus h of t1. All right, that's 700 divided by. All right, we now have to subtract t1 from t2. All right, our t2 is over here. It's a 5. Minus our t1, it's a 0. Okay, so minus 0. All right, so this will just be, how much is this? Negative 400. Negative 400 over 5. That looks like negative 80. Okay, that should be our average rate of change. Okay, and that should be it. All right, the answer is over here. There. So it's m equals to negative 80. Okay, so in units, that will be about feet per second. Okay, feet per second. Remember, in rate of change, it's one unit divided by another unit. Okay, so the h here stands for the height, which is in feet, and 5 and the 0 stands for the seconds. So if we're going to apply the units here, this is negative 80 feet per second. Okay, this will be in feet per second, like that. All right. Remember, we're using physical objects here. Okay, so it's feet per second. That completes our number 6. Let's continue with number 7. All right. Let's have our number 7. Okay, here's number 7. A particle moves along a vertical line. Its position function is st for t higher or equal to 0, greater or equal to 0. So our t stands for time. So we will not use a negative time. So it will be 0 up to some positive higher value of time. Find the average rate of change of its position in the interval 1 to 2. That will be, all right, that will be the given interval. Okay, of course, 1 and 2 is for the letter t. Okay, for the letter t. All right. So here's the given function of uh, s, function of t. All right. So f of t. All right. Now our s here stands for displacement or position. Okay. So that's the usual letter used for displacement. All right. So we will have to write the given function. We have here s of t is equal to negative t squared plus 9t plus 36. We're asked to get the average rate of change, all right, of its position in the interval 1 to 2. So 1 and 2 here are for the variable t, okay? The higher it will be called t2. The lower will be called t1, okay? the that will be called T1. All right, so this will now be T2. Okay, that will be the higher number 2, and the T1 will be called. All right, the T1 will take the number 1 there. All right, so we shall compute S T2. All right, S of T2. That means the value of the displacement time 2 there. Okay, and this is equal to all letter T's will be occupied by the number 2. So this is negative 2 squared. Okay, like that. That's negative 2 squared. We will not include the negative, of course. The negative is outside. Okay, so it's negative of the T squared. Okay, so it's a negative of the 2 squared plus 9 times 2 plus 36 there. Okay, and so this will be amounting to negative 4 plus 18 plus 36, and this will be equal to the 18 and the negative 4 gives a 14 plus the 36, and this will be about 50. Okay, so this is now 50. Okay, so S of T2 is 50. Okay, it's over here. All right, so let's continue with S of T1. S of T1 is equal to S of the value of T1 is over here. Okay, S of T1 means S of 1. And this is now negative of 1 squared plus 9 times 1 plus 36 is equal to negative 1 plus 9 plus 36 there. Okay, and the negative 1 and the 9 gives 8. Okay, so we have here 36 plus 8, so that means 44 there. Okay, so 8, that's 14, carry 1, yes, 44. All right, so we can now use the formula for slope. That's the average rate of change for the position. Okay, so this will be our formula here. S of T2 minus S of T1 divided by T2 minus T1 there. And so S of T2, that's the first value, 50, minus ST1, that's the second value, 44. Okay. And then this is to be divided, the difference of 50 and 44 will be divided by the difference in time. Okay. It will be T2 minus T1. Okay. And here's our final numerical computation. This will give 6 over 1, which is just 6 there. So the answer is 6. And so we shall see the answer over here. All right, so rate of change M is equal to 6. All right, that will be for number 7. Let's continue with the last number. That will be number 8. All right, let's continue with number 8 over here. All right, a particle moves along a vertical line. Its position function is st for t greater or equal to 0. Find the average rate of change of position of the particle over the given interval. All right, so we have here, it's similar to number 7, okay? So we will first get the function of displacement there. So this is now t squared minus 2t minus 80 for the interval 1 to 4. So the higher 4 will be our T2, okay? And our lower value 1 is our T1 there. Okay, so we shall start computing the ST2. Compute now ST2, all right, which is equivalent to S4. S of 4 is equal to 4 squared. Okay, remember the 4 will now be occupying all letter T's. So that's 4 squared minus 2 times 4 minus 80. Okay, and so this is 16 minus 8 minus 80. And so how much is that? We have here 88 and 16, okay? 88 and 16, that will be about 2 and 7, sign of the higher, like that, okay? 88 and 16, so we have a 2 and a 7, sign of the higher. All right, so that's it. Let me remove my scratch. All right, so that goes to ST2. Let's have our ST1. Okay, ST1 means S of T1, which is the number 1 here. That is equal to 1 squared minus 2 times 1 minus 80. All right, we're using this, of course. There, okay? All right. So this is now simplified to 1 minus 2 minus 80, which calculates to 1 minus 82. And this looks like negative 81, okay? So this is negative 81. Okay, so we have the two values, okay? Negative 72 and negative 81. That's S of T2 and S of T1 respectively. All right, so we are now ready to compute our M, or slope. Okay, the slope is actually the average rate of change. All right, so we will now write the formula for slope. It's M. Okay, there's the division symbol. This is S of T2 minus S of T1 divided by T2 minus T1. All right, let's write the numbers equivalent to this. ST2 is negative 72. Okay, minus is part of the formula. After that minus, get the second number S of T1. That happens to be a negative 81. So you write negative 81 there. And then this is divided by T2. All right, T2 is over here. That's 4. Minus is from the formula. Get your T1. All right, that's a 1. And this is now negative 72. Minus negative becomes plus. You have there 81. Over 4 minus 1, that's a 3. Okay, so negative 72 plus 81, that will be about 81 minus 72. That will be about 9. Okay, and divided by 3, that's exactly 3. So our M is equal to 3. There. That's the answer. And so we'll be able to verify that over here. So rate of change M is equal to 3. And you can see it using the red writings here. There. So that's the answer. M is equal to 3. All right, that completes our discussion. I think this is the last number. And so, all right, that will be all for this discussion. And we shall continue with the next lesson later. So I hope you were able to learn how to solve problems and finding average rate of change. All right, so see you later. Bye-bye.